So the Pythagorean theorem is named after a Greek mathematician named Pythagoras, who discovered this theorem that has specifically to do with right triangles. So the first thing I want you guys to do before I even tell you what it is to underline in that box that says Pythagorean theorem. I want you to underline right triangle, like maybe a couple times. It only works for right triangles. How do we know if a triangle is a right triangle? It has a little square in the corner, okay? The reason why we do this is because the Pythagorean theorem is a standard that you only get in Math 8, and you guys are not in Math 8. You skipped it, so because technically this is Math 1, like that, the title of your book. So we have to do this specifically for you because you will be expected to know it from here on out, and no one will ever actually teach it to you. So that's why we add it in here. Jonah. The reason why we do it here is because it specifically has to do with distance. So 7.6b is midpoint and distance formula, and the distance formula comes directly from the Pythagorean theorem. So back in ancient Greece, there was not a lot to do. So a lot of the ancient Greeks did math for fun. They did they wrote, they had philosophical conversations, and that's really what they did, and that was their job. So if you were an academic type person, your job was to sit around and think about math or other things, science. And Pythagoras was a mathematician, so he did all of this work. The story kind of goes that paper was expensive, right? Do you guys remember in 6th grade when you learned about Egypt and you did like paper? Did anybody actually make paper in your class? Okay, when I was in 6th grade, we made paper. And paper was expensive, and it was a time-consuming process to make. So they didn't waste time writing this stuff down on paper. They did it in the dirt with a stick. I'm not joking. I know. And then if they discovered something, then they would write it down on paper. So Pythagoras discovered that if he had a right triangle and actually measured the lengths of the right triangle, that the two legs squared added together was equal to the diagonal squared. Now, each of those have names. So what is typically called A and B are called the legs of the right triangle. So a right triangle has two legs. That looks like Lego. There we go. And the diagonal part of the right triangle, which is opposite of the right angle, is called the hypotenuse. Okay. So if we have a right triangle, and usually we just label the legs A and B, and the hypotenuse is always C, Pythagoras discovered that if you take A squared plus B squared, it came out to C squared. Okay? There are hundreds and hundreds of different ways to prove that this is a true statement. So remember when I talked to you guys about postulates, and postulates are just statements that we take for fact, like we say this makes sense, we're going to say that it's true. A theorem actually has to be proved. So there are over 100 different ways to prove that this theorem is true. Okay? One of these days we'll look at a couple of them, but for today we're just going to work with it. So really that's all you need to know. The biggest thing that you guys need to be aware of when you are working with the Pythagorean theorem is that A squared plus B squared equals C squared, but another way to say this is leg squared plus leg squared equals hypotenuse squared. Okay, so the C is always the hypotenuse. It's not always going to be your unknown, and that's something that students get confused with occasionally. And if you guys look at our paper, our triangles are all going to be facing different ways and kind of curved a little bit. So the hypotenuse is always diagonal from the right angle, so that's how you will know which one the hypotenuse is. You ready to do a couple? Sure. Okay, I'm going to start you with an easy one. So number 1, we have legs of 8 and 6, and my hypotenuse, it's not, there's no variable attached to it, so I'm going to label it C. And we're just going to plug everything into the Pythagorean theorem. So this is going to be 8 squared plus B, which is 6 squared, and it doesn't matter which one is A and which one is B, equals C squared. And this is how I want you to show your work. Guys, what's 8 squared? Good. What's 6 squared? Good. And then equals C squared. 64 plus 36 is 100. And then here's the tricky part. 100 equals C squared. I need to undo that square. Does anybody know what the opposite of squaring something is? Not a cube root, a square root. Okay, so you guys know how if we're adding to undo it, we do subtraction. If we're multiplying to undo it, we do division. If we are squaring something to undo it, we square root it. Guys, what is the square root of 100? 10. So C is equal to 10. Not too bad? What do you guys think? Okay, let's do one where I give you the hypotenuse but not one of the legs. So number 2, across from the right angle is 5. So that's actually your hypotenuse, making 3 a leg. So we're missing one other leg. I'm going to call it B. Okay. So we plug everything into the Pythagorean theorem. A squared, which is 3, plus B squared, we don't know what B is yet, equals C squared, which we know is 5. And we do the same thing. So 3 squared is 9, plus B squared equals 25. And before I can square root, I have to get that B squared by itself. So what am I going to do with the 9? Good, subtract. So that's going to be B squared equals 16. And then to undo that B squared, we square root. Square root of 16 is 4. Bless you. So Jonah asked a really good question. What happens if what you get is an irrational number, meaning you can't take the square root of it? That's going to be like number 3, so let's do it really quick. What am I missing, guys? A leg or the hypotenuse? Hypotenuse. So let's label it C. So we're going to plug everything in. 3 squared plus 3 squared equals C squared. 3 squared is 9, so 9 plus 9 equals C squared. So 18 equals C squared. Square root both sides. And I'm gonna show you 2 different ways of doing this. So I want you guys to make sure you're with me. So the first way that you can do this, because these are lengths, is you can plug in square root 18 into your calculator. Okay? So in my calculator, I can do 18 square root, which comes out to 4. Let's do 2 decimal places. So 4.24. There is a second way of doing this. So let me move this over. And I think that all of you should be comfortable with just plugging it into a calculator, right? Okay. We also have what's called radical notation. So normally in 8th grade you wouldn't be doing this, but because you guys are going into Honors Math 2 next year, you will be expected to do this. So we're just going to practice. So let's go back to this. Square root 18 equals square root c squared. Radical notation means that I put my answer in the most reduced radical form. So if I am looking at square roots, that means squaring something means that I'm looking for a number times itself, right? Yes? So I'm looking for pairs. So if we break down the 18, how can we break down the 18 using a factor tree? Do you guys remember this from elementary school? 2 times 9. Okay, and can 2 be broken down anymore? Can 9 be broken down anymore? Yes, 3 and 3. So the factors of 18 are 2, 3, and 3. Is everybody okay with that? Yes? Okay, do you see any pairs of numbers? 3 and 3. So if I am looking for pairs because I'm looking for a square root, I can pull that pair of 3's out of the square root. And it becomes a 3. Inside the square root, that 2 stays there because there are no pairs. And that's radical notation. So we pull out, another way to look at this is, can you take the square root of 9? What's the square root of 9? 3. Can we take the square root of 2? No, so you leave it inside. So you're looking for perfect squares. We're going to just practice this. So square root of 18 is 4.24, or 3 square root 2. And if you take your calculator, plug in the square root of 2, and then multiply what you get by 3, you end up with 4.24. These are identical. Okay? 4.24 is more of a measurement way of writing it. 3 root 2 is more of an algebraic geometry way of writing it. For you guys, I want you to give me both. On the test, I don't care which one you give me, either one. But for homework practicing, I want you to give me both. So let's look at number 4. I have a leg, root 3, and then 8. Is that the hypotenuse or a leg? Okay, so how we're going to plug this into the Pythagorean theorem. Root 3, put it in parentheses. So the square root of 3 squared plus b squared equals 8 squared. And then we have to plug all this stuff in. So let's think about it. If I have the square root of 3 and I'm squaring it. Squaring means a number times itself, right? So square root 3 squared is square root 3 times square root 3. Is everybody good with that? What's 3 times 3? Okay, so is everybody okay that that is the square root of 9? What's the square root of 9? 3. Okay. See a pattern? So could I have gone straight from here to here? Okay, quick quiz. If I give you square root 5 squared, what do you think it's going to come out to? 5. If I give you square root of 237 squared, what's it going to come out to? 237. Why does it work? They undo each other, right? Okay. So the square root of 3 squared comes out to 3 plus b squared equals what? 64. I want you guys to finish this problem for me. What was your next step?
Subtracted the 3 from both sides.
And you got b squared equals?
61.
Good, 61. And then, AJ, what did you do after that? Good. Square root each side, and you got b equals 7.81. You guys agree or disagree? Okay. The other way you could have written your answer is b equals square root 61. So there was no way to reduce that square root 61, so that is as much as you do, and the whole thing stays in the square root. Okay? Because it's a prime number. Not too bad? Okay, here's what I want you to do. For number 5, set it up, but don't square anything yet, because that 2 root 3 takes a little bit of explanation, but I want you to set it up. So set up the problem. Okay, Elizabeth, read me what you plugged in. Plus b squared. Perfect. Thumbs up if you agree with Elizabeth. Excellent. Okay, so really quick, guys. 2 root 3 squared. That means 2 root 3 times what? 2 root 3. Okay, we already did the root 3 squared part, yes? We also have to do the 2 squared part. Okay, does that make sense? So we multiply 2 times 2, which is what? 4. So let me move this over to the side for a second. So 2 squared gives me 4 times, what's root 3 times root 3? Root 9, which is 3, plus b squared equals 16. Let me erase this. And what's 4 times 3? 12. Plus b squared equals 16. So when you have radical notation and there's a whole number on the outside of the radical, you also square that. So you square the whole number, you square the square root, and then you multiply them together. Okay? So 2 squared was 4. Root 3 squared is 3. 4 times 3 gives me 12. And I'm going to keep it in parentheses. Okay? That's probably the trickiest part out of all of these. Subtract 12, so you get b squared equals 4. And then this is an easy one. What's the square root of 4? 2. So b equals 2. Okay? Pythagorean theorem, how do you feel? Thumbs up, thumbs down, in the middle? Pretty good? Okay. You guys will have some more practice with this, but I want to make sure we can get through everything, so we're going to keep moving on. But all of this that we're going to be doing is the Pythagorean theorem, so it's just a lot of the same thing over again. Okay? Turn the page really quick. Something else that you have to be able to do in 8th grade, which is kind of difficult, is finding the diagonal of a rectangular prism. So let me go get a visual aid for you. First of all, I want you guys to look at the drawing. Is there a way that we can make triangles out of this? What do you think? Because we know a little bit about triangles now. Jen? From here to the other diagonal. Okay, so she is saying if we could draw a line from there to there, and does that make a right triangle? From here to here. This is not going to be very straight, but you guys see the right triangle? Okay. Do I know the length of this diagonal? No. Could I find it? Possibly. But we need to make another triangle. You guys see how we could make another triangle so we can find the length of this one? The other way. What about this right here? The right angle is right here on this one because it's the bottom of the box. Do I know my length? Do I know my width? Yeah, it's the same as that right there. So let's label it width. So we can use the Pythagorean theorem to find the diagonal along the bottom of the box. This part. Right? And then do it again, but this time the right angle is right here. So what was our diagonal will become a leg. Do you see what I'm saying? Kind of? It's hard to visualize, especially if you are not a visual person. So what we are doing to find the diagonal, we are finding the diagonal along the bottom, and then that's going to become a leg on the more three-dimensional triangle. So how do we do this? The answer is very carefully. So you guys know the Pythagorean theorem. Let's call that diagonal x. And we're going to go through all of this, and it's going to get kind of complicated, and then it's going to make a really nice, easy formula for us. Okay? So we have to do the blue triangle first, correct? Okay, so how would I find the length of x on the blue triangle? Use the Pythagorean theorem. So one of our legs is w, so width squared plus what? Length squared is going to equal x squared. Everybody okay with that? Okay. Now, when we actually do a problem, there will be a length, a width, and a height for you. Okay, so these will all be numbers. If I wanted to keep it like the way that it is, how would I get x by itself? So how do I get rid of that square on the x? I square root both sides, right? Okay, so we're going to square root the whole thing. So I just want you guys to rewrite this. X equals the square root of w squared plus L squared. When we're actually doing the problem, we will have numbers in there. Or let's just... Okay. So then, now we have enough information to do the red triangle, because now I can substitute a value in for x. So let's just rewrite it right now. Here's your height. So x squared plus h squared is going to give me d squared, the diagonal. Do I have a value I can plug in for x? W squared plus L squared. So, square root of w squared plus L squared plus h squared equals d squared. Bear with me for just a second. It's going to get better really fast. When I square something that has a square root in it already, what did we get? Just the same thing. Square root of 3 squared was 3. Square root of 5 squared was 5. Square root of 237 squared was? Square root of w squared plus L squared squared is? Yep, w squared plus L squared plus h squared equals d squared. Will we know what w, L, and h are? It's going to be given to us. So Put a big old box around that whole thing. And actually, we could take it one step further. Before you put a box around it, what's one step further we could do to get the D by itself? Not cube root, square root. Oops. Sorry. You could also square root both sides. So then, nice and big, let's put D equals, the square root of W squared plus L squared plus H squared. So basically you square all the parts, add them together, and then take the square root. And that's going to give you the diagonal. We're just going to do one of these. Okay? It's a lot. But, and this is very conceptual, but you have to have at least seen it. Okay? So let's do 10 because I think it comes out nice. So let's do 10 together, and then we're going to move on. So number 10. I have a length, a width, and a height. I'm looking for the diagonal. So remember, we just did it. D equals the square root, and make it a nice long square root, of W squared, so 4 squared, plus length squared, 3 squared, plus height squared, 12 squared. So we're going to find all those, then we'll add them together, and then we'll do the square root last. So, square root. What's 4 squared? What's 3 squared? Anybody know 12 squared? Good. Okay, somebody with a calculator, will you add those up for us? 169. Does anybody know what the square root of 169 is? Right off the top of your head? This is going to be one that you will have memorized. 13. So D equals 13. That wasn't too bad, right? Okay. That's really about as hard as it's going to get. Sometimes this will not be a perfect square, so you'll have to give me a decimal as your answer or in rational notation, but that's pretty much as hard as it gets. Okay? Questions or concerns? Jen? Okay, good question. She said, will they ever not give you one of the measures? It's very possible that they will give you the diagonal, but not one of these, so you can work backwards, but I've actually never seen it. I've always seen where they give you the length, the height, and the width. But it is possible that they don't give you one of those and they give you D instead, and then you would just have to work backwards. Yeah. The letters you use, you have to, oh, so like if you use capital D, technically they're supposed to be. If you don't, it's not going to kill. Like we'll know what you mean. But when we're talking about distance or length, it's almost always a lowercase letter. Good question. Okay.